Okay, today's video is lesson 3.1. This is integer bases with exponents. This should be page number 22 in your interactive notebook. Let's go ahead and talk about the goal today. So for today, our goal is to simplify expressions that include integer bases with exponents, and you'll see what that means as we go through 5 examples today. Actually 6, I think. There's really only one key term that we need to discuss, and that is the idea or the definition of what an exponent is. And we use exponents to write repeated multiplication. So it's used to express repeated multiplication. So if you look at this example below, we've got 8 to the third power, where 8 is the base number and the exponent is 3. So we can say that 8's being taken to the third degree, which means that the 8 is being multiplied by itself 3 times. So 8's being multiplied by itself 3 times. And the exponent will always tell you how many times the base number or variable is being multiplied by itself. So what we can say here is that 8 to the third power equals 8 times 8 times 8. You see how 8's being multiplied 3 times? These two, when evaluated, would give us the same answer, and I'll show you that right now. We've got 8 times 8, which would be 64, times 8, which would be, and I'm going to use the calculator for this, so we got 64 times 8 would be 512. Well, what if we just typed in 8 to the third power? We would say 8 to the third power, we got x to the third, 8 to the third power equals 512. So that is the same exact expression. These two are the same exact expression. So let's go ahead and get in a couple examples today. So here we have 5 squared. So that's the same thing as saying 5 squared equals 5 is the base, and we're multiplying it by itself 2 times because we see the 2 as an exponent. So the base here is 5. How many times are we multiplying by itself? We're multiplying it by itself twice. So 5 squared, or 5 times 5, we can do in our head, it's mental math, is 25. So the answer we would get is 25. And I'm actually going to switch colors here so that you know what the answers are. Use white. 25. Example number 2. So here we have 2 examples, and I'm going to go ahead and write one right here for us. I'm going to say negative, whoops, all mixed up right now. I'm going to go ahead and say negative 3 to the 4th power. So very, very similar problems, but there's a very distinct difference that I want you to realize after we go through both these examples. So here we've got this negative 3 in the parentheses. So the negative is being taken to the 5th power as well as the 3. So we can just say that the base here is negative 3. And how many times are we going to multiply negative 3 by itself? We're going to multiply it 5 times. So negative 3 squared equals negative 3 times negative 3 times negative 3 times negative 3 times negative 3. So we've multiplied negative 3 by itself 5 times. And if we were going to simplify this just using our own shorthand, we would say negative 3 times negative 3 is positive 9. Positive 9 times a negative 3 is a negative 27. Negative 27 times a negative 3, I'm going to go ahead and use the calculator for this. So we've got negative 27 times negative 3 is a positive 81. And then finally, positive 81 times a negative 3 is going to be a negative 243. So that would be our answer, right? However, since I have the access to a calculator, and this should say 5, not 2. I don't know why it says 2. Since I have access to the calculator, I can go ahead and just punch in parentheses negative 3, and then if I want to get something to a power that's greater than 3, I'm going to use this xy, where we just say caret, and then we want to open it to the 5th power. So we can say negative 3 to the 5th power is negative 243. And that's what we got. So that would be our answer here. Now, example number 3 is very similar to example number 2. However, the base is not negative 3 in this example, and you're probably thinking, why is the base not negative 3 when I see negative 3? Well, in example 2, the negative was inside the parentheses, so it was included in the base. In example 3, there's no parentheses, so the only thing that's being taken to the 4th power here is the 3. The 3 is being taken to the 4th power, the negative is left out. So the base is 3. The number of times we're going to multiply it is 4. So we've got 3 to the 4th power equals 3 times 3 times 3 times 3 times 3, 4 times. And whatever that equals, we're just going to bring down this negative. So we're going to figure out this, and then it's going to be some negative number because we're bringing the negative sign down. So 3 to the 4th power, well, we know that 3 to the 4th power, or negative 3 to the 4th power is 81. So if they're all positives, positive 81, but we're bringing down the negative, so it's a negative 81. So go ahead and make a side note in your notebook that when we have a negative in parentheses, it is included, right? And when we have a negative outside parentheses, it is not included. So that will matter when you put it into the calculator. We got 3 more examples today. And this is another special case. So we've got 9 to the 0 power. Well, the base here is 9. And how many times are we multiplying it by itself? 0 times. So whenever you've got a number to the 0 power, your answer will always be 1. Except for 0 to the 0 power, that would just be 0. So this is actually a mathematical property. When you see 0 as an exponent, no matter what the base is, the answer will always be 1. So we can say that x, representing any number to the 0 power, equals 1. Except x cannot equal
Gabriela Gonzalez.
So we can say, if we had 1001 to the 0 power, that equals 1, right? Negative 14 to the 0 power, that equals 1, right? 0 to the 0 power does not equal 1. That's the one exception. 0 to the 0 power equals 1. So these two apply here. This applies here. This does not equal 1. This is no good. 0 to the 0 power equals 0. So if we look at example number 5, we know that 9 to the 0 power, taken to the 0 power, equals 1. However, it's not a negative 9 because we have no parentheses. So our base here again is 9. It's being multiplied by itself 0 times. So we know that 9 to the 0 power equals 1. And we're going to go ahead and bring down this negative, so it actually equals a negative 1 for our answer. Last example today. This is negative 9 to the 8th power. We've got negative 9 to the 8th power. The negative is inside the parentheses, so it is being taken to the 8th power as well. So our base here is going to be negative 9. And how many times are we multiplying it by itself? We're multiplying itself by 8 times. So I'm going to go ahead and use the calculator to do that. And I'm going to put it in parentheses. That way the calculator knows the negative is included. And we're going to use the xy to open up the power. And it's the 8th power, so we're going to use 8. Hit enter. And you can see that we've get this number, which is, let's see, ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions. So we've got 43 million and 46,721 is our answer, right? However, when we put this into Schoology, we do not need to put commas for our places. We can just say 4, 3, 0, 4, 6, 7, 2, 1 would be our answer in Schoology. Good luck on the homework.